This Explain Everything project is designed to show you how to use trigonometric ratios to find missing measurements in a right triangle. First, we have to remember that SOHCAHTOA stands for something. SOH stands for sine equals opposite over hypotenuse. SOH. The CAH in SOHCAHTOA stands for cosine equals the adjacent leg over the hypotenuse. And the TOA is tangent equals the opposite leg over the adjacent leg. Now, before you even begin to decide what opposite leg is, hypotenuse and adjacent leg, you have to have a reference angle. In this case, our reference angle is angle X. I have it here marked in red. Now, the hypotenuse is always opposite the 90-degree angle. Now, you find out what's opposite if you put your pencil on the 90-degree angle and go straight across the triangle like this. That's your hypotenuse. It's the longest side of the triangle. The opposite leg is across from your reference angle. So just like you referenced the hypotenuse in the 90-degree angle, the opposite leg is across from our reference angle. And the adjacent leg touches the reference angle. Adjacent means touching or next to. So let's see if we can set up some of these trig ratios and solve some right triangles. We can see that sine is opposite over hypotenuse. I don't want to use hypotenuse. So that means I can't use cosine. Tangent is the one I want. Tangent involves the opposite and adjacent legs. In this first example, we're going to try to find angle C and our two missing sides. Now, I'm given two pieces of information. I'm given angle B is 32 degrees and AC is 8. Now, before I even begin, I'm going to label this side. We know that is a leg because it makes the right angle in this right triangle. It's clearly not the longest side of the triangle, so it's not the hypotenuse. Angle B is directly across from that 8. So that makes 8 the opposite side. So I'm going to label that OPP. Okay, the first thing I'm going to find is going to be one of our missing sides. You can start with any side that you want, but remember, B is our reference angle. In this case, I'm going to start finding AB. So that is this side right here. I want to find this side. Now, segment AB touches angle B, touches our reference angle, and if you remember, adjacent means next to or touching. So that's the adjacent side. I'm going to label that with an ADJ for adjacent. Now, why did I label these two sides? These sides have to be labeled so I can go back to my trig functions and see which function, sine, cosine, or tangent, uses adjacent and opposite. So if I just... Okay, so I know I want to use tangent. What I have to do is I have to set up my trig ratio. So I'm going to write down the tangent of my reference angle, in this case, which is 32, should be equal to my ratio, which is opposite over adjacent. So that would be 8 is my opposite leg, and the adjacent leg I don't know, so I'm going to put an X there. Now I have to solve for X. If X is on the bottom of the fraction like it is here, to solve this, I can either write out two steps, or you can take the shortcut that I showed you in class which is just to switch or swap this x and the entire thing, the entire term over here to the left of the equal sign. So I'm going to totally switch x and the tangent of 32 and rewrite a new equation. So x is equal to 8 divided by the tangent of 32. All you have to do is plug that in your calculator and round to the nearest tenth. And in this case, I come up with 12.8. So side AB is 12.8. Now I can use the same trig functions, the same ratios to find side BC. The only thing I have to change, I'm no longer using this side, this adjacent side. I'm using, this time, the hypotenuse, or trying to find the hypotenuse. And I'm going to use my opposite side in my hypotenuse this time. So if you go back and take a look at those trig functions, the trig function that uses opposite and hypotenuse is the sine. So I'm going to rewrite the sine of 32 is equal to, in this case, opposite, which is 8, over hypotenuse, which I'm trying to find, so that's x. Notice the only thing that changed in here was the trig function. Tangent used the two legs, and sine uses the hypotenuse and a leg. The opposite leg, to be specific. But I follow the same procedure to solve this. I'm going to swap my x and my sine 32 and rewrite a new equation. So x is equal to 8 divided by the sine of 32. If I put that into my calculator, 8 divided by the sine of 32, and round to the nearest tenth, I get 15.1 for an answer. Now finding my missing angle, in this case angle C, is really easy. Since we know that all three angles in a triangle add up to 180, and this angle A is 90, that means that angles B and C have to add up to 90. So to find angle C, all I have to do is subtract 32 from 90. So angle C is equal to 90 minus 32, which is 58 degrees. So my three answers for my adjacent side, I have 12.8. My hypotenuse is 15.1. And my missing angle, angle C, is 58 degrees. Let's look at another example. In this example, I'm given two sides of the right triangle, and I need to find both angles and my missing side. So I need to find angle R. I'm just going to put a little space for me to write my answer there. I need to find angle T, and I need to find the length of segment TA. To do that, I can set up to find angle R, if that's what I want to do first. You can start, again, you can start with any angle or any side that you want. There's no set order to this. In this case, I'm going to start with angle R. If I use angle R as my reference angle, the side that's labeled 8, if you look carefully at the triangle, is the hypotenuse. The side that's labeled 7 is the adjacent side. The trig function that uses hypotenuse and adjacent is the cosine. So I'm going to set up my trig ratio. Cosine of angle R is equal to the adjacent over the hypotenuse, so 7 over 8. Now to get angle R by itself and get rid of the cosine, what I have to use is the inverse cosine. So just like subtraction is the inverse of addition, when you're solving an equation, if I had 6 plus x equals 9, I would subtract 6 from both sides because 6 is being added to the variable. Here, I want to get rid of the cosine and leave the r only. So to do that, I have to take the inverse cosine. Remember, this is not cosine times r. Cosine is a mathematical operation, so we need to do the inverse of cosine. And that looks like this. R is equal to the inverse cosine, or cosine to the negative first power, which you'll find right above the button on your calculator, right above the cosine button on your calculator. You'll see cosine to the negative first power. In most calculators, you hit second or shift and then hit the cosine to get that. And then I have my ratio. So I'm going to find the inverse cosine of 7/8. And when I do that, I get 0.28955. And if I round to the nearest whole number, I get 29 degrees. So angle R is 29 degrees. To find angle T, just like in the last triangle, all I have to do is subtract 29 from 90. And when I do that, I get 61 degrees. So angle T is 61 degrees. Now to find TA, you can use trig again if you want. If you do, you have to use the fact that TA, if we use R as our reference angle, TA would be the opposite side. And I could use either the hypotenuse or the adjacent side along with TA. But in this case, I'm going to use Pythagorean theorem. Now Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. The legs can be interchanged, but 8 is going to have to be put in place of c. We'll say my first side that I'm trying to find is TA, so I'll leave the a there. My second side, RA, is 7. Square the 7 and the 8 to start solving this equation. 7 squared is 49. 8 squared is 64. I'm going to subtract 49 from both sides. And when I do that, I get a squared is equal to 15. Now to solve for a squared, remember, means a times a, not a times 2. So I have to square root both sides to get my answer. And a is equal to 3.9 if I round to the nearest tenth. So TA is 3.9. And I'm done.